Okay, so today we are going to talk about data analytics. Okay. Um, this is the concept that is not strange to you, right? Over the media, or even the professors, the students around you probably talked about data analytics very often. And in fact, this is a becoming increasingly important tool for the future contents. So data analytics involves analyzing data using softwares and statistics to draw inferences, right? So when you have large amount of data, right, they're just data, right? You won't be able to see anything through those numbers, right? Unless you start using softwares, statistics softwares, to do a little bit of analysis, and then you can make make sense of it out of it, right? So that is the power of this type of analysis because it enable you to find some interesting relationships. You can draw some interesting conclusions by um, analyzing this data. Okay. So the use of this technique is becoming increasingly common, including different softwares, right? We have Power BI, um, we have Tableau, right? Make it visible, right? And on the bottom, there are four common types of data analytics. They go based on the level of the question, right? The first question is very descriptive. What happened, right? That's a descriptive question. We call this descriptive analytics. For example, um, in this database, in this survey, okay, we found 60% of the population, the respondent, okay, are females. Only 40% are males, right? So this is a description, just to describe what happened, right? Why did it happen? Diagnostics, right? So why there are more females people participating in the survey, right? So once they're asking why, that's become very interesting. Diagnostics. And then predictive, what is likely to happen, right? So you know this is what's now, what is likely to happen, right? So that's predictable, right? That's predictive. And then another one is what should we do about it? Prescriptive, right? Um, you ask very good questions. First, you learned what happened, and you try to understand why that happened and how that is going to affect the future, right? And now the question is, okay, what could we have done, or what we could do, um, to make it the way that help us, right? So prescriptive. So what we should do, right? If you take a look at these different levels data analytics, it goes from descriptive, diagnostics, right? This is the past. You rely on the past information, right? Because this information will tell you what happened and why did it happen, right? So you rely on the historical data to describe what happened and why it happened. And then you are seeing the future, right? What is going to happen and what should we do about it, right? So you can see that as you move from the past to the future, this analysis become more valuable and it's more complicated, right? When you think about you know what happened, the historical information, that's the hindsight, right? When you are trying to understand the future, that's the foresight, right? Okay. And this information analysis will give you some insight, right? So you can see how that tie into these different levels of data analytics. Okay. So there are some misperception about this fundamental analytics, right? So one misperception would be this is like a magic, right? This is like a magician magic. Um, one end you get the data in, on the other end the answer was out. Okay. The business analytics actually rely on data, rely on conceptual framework, and the computer model. Okay, so that's important. It's not just the data, right? It's the conceptual frameworks and the computer model. So there are some examples of companies using analytics. So FedEx, right? FedEx, they use analytics to explore new business opportunity. Amazon, they use analytics to establish new strategy. And the strategy is very interesting. It's called first shape and then buy model. Okay, because of the amount of the volume, the consumers' shopping behaviors. This is all right information recorded by Amazon, right? So Amazon will analyze this information, including when you most likely to shop at Amazon. It's in the early morning or in the evening. What kind of product are most attractive to you? Okay. And how old are you, right? You have kids, right? Because if you start shopping a lot of product that are used by the babies, that right away, Amazon will be able to analyze that data to know that this customer has baby, right? And if you always buy tools, right? People, Amazon will know, oh, you must be a handyman, right? You must be a handyman. So based on your shopping behaviors, based on the information you will interact with Amazon website, you left tons of information data to the company that they can use it to analyze your information. So the idea is the machine learning, like Amazon has the machine learning, they will be able to learn each customers, right? And then they're gonna predict your need. Okay. So based on your last 2 or 3 months shopping, Amazon wants to predict what you're gonna need, right? What are you gonna need? And then guess what? Before you even order this item, Amazon probably knew that before you knew it. Amazon will first send it to you, and you will keep it only if you want to buy it. So this is called first shape and then buy model, right? So you open the door, there's a box shipped to you from Amazon. You open it up. Wow, this is exactly what I need, right? Amazon is so smart. Amazon is able to predict what I need before I even make an order. So now this item just sent into in front of my door. You opened, you like it. Guess what? You sign and you buy it, right? So that's what's happening right now, right? Amazon's first shape and the then my buy model. If you open it, you don't like it, then you just return it, right? The analytics can also help business to solve more complex critical business challenges. For example, Air Canada, right? How are you gonna schedule your flights, right? You have different uh, airports across Canada, right? Different routes, right? So how are you gonna scheduling your routes, right? Um, so for example, Major League Baseball games. Well, when they playing games, well, they need to do the scheduling, right? Between different baseball teams, right? And then they need to know what's the most popular time when people are available to watch these games, right? So when they are scheduling, they have to understand based on the historical information. If you use analytics, this is your competitive advantage, okay? Because you know, if you use analytics, right, you are able to make a better causal relationship, right? Causal relationship means that you are better able to address the uncertainties in the business. So for example, if I'm an ice cream shop, right? If I'm an ice cream shop at a location, if I have analytics, it's going to help me a lot, right? So for example, I want to know, right, what the customers look like, how old are they, at what time they usually shop at my ice cream store. Okay, is in what weather? Is when it's really hot. What is the temperature, right? So if you are able to record the sales, the temperature of the day, right? Maybe you are able to make a linkage, right? The hotter the outside is, you have better sales, right? And you even know what's the ratio, right? Based on the historical data. Okay. And then what are the time they are coming to shop to get the ice cream, right? And then you'll be able to analyze, should I open the store all day around? Or maybe I should just open from, you know, this time to this time to capture the majority of the customer. And then I close the store to save the cost, right? For the remaining time. Okay, so only if you have this tool, it definitely help you to do a better business, right? As we mentioned, okay, this level of analytics goes from descriptive, what happened, to diagnostic, why did it happen, to predictive, what will happen, to prescriptive, what should we do about it? And now the highest level is the cognitive self-learning. What don't I know? Okay, what don't I know? I heard a story, it's very interesting. Basically, it's saying that what is called the target knows better. So this story goes like this. In United States, there is this retailer called Target. I think back 10 years ago, Target even entered into Canadian market, but that move wasn't proved to be a very bad move. So they were not very successful in Canada. So they exited. They closed all the store. They left Canada. But they are still a strong retailer in US, right? So they were saying that a father, a daddy, and a daughter, right? They went together to shop in Target, okay? And then as they check out the items, okay, the Target right away learned something that the father didn't know about the daughter. So the Target right away learned that the daughter was pregnant. Okay, just based on the things she was buying, Target right away know, right? So this customer most likely to be pregnant, but the father didn't know, right? It's quite amazing. So that's why this is self-learning analytics, right? Why don't I know? Why don't I know? So basically, you want to learn about your consumer, right? The Amazon wants to learn, study each consumer to know, to predict what is the next thing he's going to order. So that's pretty crazy, right? So Amazon knows about you better than yourself. Isn't that crazy? So you probably think that you know yourself better than anyone else, right? Right? But all your behavior, right? All your actions, those are become data nowadays, are captured by the company. And once they study your data, they know a lot of more information about yourself than you know yourself. Okay. Let me give you an example of descriptive analytics, right? What is the descriptive analytic? So for example, I have this data, I have the day, I have the height, okay? I have the day, I have the height, okay? So then I can use the stats to figure out what's my minimum, okay? And what's my maximum, and what is the average, okay? So this is very descriptive, right? You did diagnostic analytic. So this one, for example, okay, you are able to see some outliers, right? So you can see this single apple in the midst of oranges, right? So basically, diagnostic analytics help you to uncover patterns. So mostly orange, except one outlier apple, right? And the shopping pattern isn't interesting. This is really funny. So psychologists did many experiments to understand the different shopping patterns of men versus women, right? So basically, the left picture shows the shopping pattern of a man. So you go into the store, you get what you need, and you left it right away, right? Okay. I and then the right picture is the woman's shopping patterns. So you go like, did you see how the shopping path? They just go back and forth, just look around, just spend a lot of time there. Um, how many? We probably have some men and women in this class right now, right? I just had a good laugh because in my own experience, this is so true, right? Like when I go to shopping, I know what I want. I just go in and I don't even want to look for it. I go to ask, where is that? I go ask the staff, where is it? And they tell me which aisle. And then I go directly there and I pick it up, I check it out, and I left, right? But my wife, when she's shopping, yeah, she has to go through every corner, search very hard. But at the end of the day, she may not spend any money, but she just enjoy that experience. Yeah. Um, and it's funny because this. So IKEA, any of you have been to IKEA? If you have been to IKEA, please give me a thumb up. Maybe you guys are too busy. You don't have time to shop in IKEA. Okay. So you go to IKEA, you can't get out that easily, right? So um, the way how they set it up is that they force you, if you want to exit, right? They force you go through all the sections of all the items, right? So that's kind of force you to adopt a woman's shopping pattern. Okay. So like for me, I want to quickly get out of it. No, in IKEA, if you want to get out, you still have to follow the path that will actually show you when you walk along the path, you have to see all the items, right? So they force you to see all the items on the path exiting the store, right? So it's funny because it's just one way in and one way out, right? You can't go backward. So with this kind of pattern, right, you uncover the pattern of a women's shopping behavior, and that's why IKEA would be really attractive to the woman, right? So predictive analytics, right? So you can see the different colors. They kind of clustered in their own area, right? So this allows us to predict there are maybe three, right? There may be three groups, right? So by seeing this, I'm able to predict there are three groups, right? And then based on other attributes, I probably are able to assess, right, which that item belong to, right? Which that item is belong to. Predictive analytics would be also using regression, right? This one is about the classification. You classify them into different groups. This one is about the regression. You have done this before, I'm sure. This is about linear regression. So basically, this is done in Excel. You have a bunch of data points, and then you ask, I want to have a linear regression, and they will tell you that equation. So it's y equals a constant plus a slope times x, right? So in this case, so they tell me that the time in weeks with cumulative saving. So, and the trend is going up, tells me when you allow the longer time, you're gonna have save more money, right? What is the relationship? It tells me every week seems like you can save $307.50. Okay, based on this linear regression, it tells me based on that trend, analyzing this trend, we learned that you have $400 to start with, and every week your savings increase by around $307. This linear regression does not always guarantee a causal relationship, right? You may find some very interesting association, but there may be a causal relationship, right? So my birthday is on May 30th, 31st, okay? And in 1 year, the final NBA exam, final NBA game is between Toronto Raptor and the Golden State Warrior, right? So, and it happened that there are many people gathering on May 31st to watch the game, right? So then I'm thinking, wow, my birthday is May 31st. And I'm really important. On that day, people walked out, gathered at the downtown Toronto, right? They're celebrating, right? So I cannot make a causal relationship saying it's just because they happened on the same day. That doesn't mean that they came out to celebrate for my birthday, right? And then oh, actually what? Actually, there's a game also happened to be on the same day of my birthday, right? Okay, so this is the one other example, chocolate consumption, Nobel laureates, right? So the map is showing that actually for a country, if you consider how many Nobel laureates, okay, from that country, it's actually affected by the country's chocolate consumption. You can see China, they have no Nobel laureates, right, per 10 million population, and their chocolate consumption is very low, right? And then if you see Switzerland, for each capita, each year they consume 12 kilograms chocolate, and guess what? For every 10 million people, there are 33 Nobel laureates, right? So then you can see it's interesting how that affected, how this chocolate consumption affected the number of the Nobel laureates. But that's not a causal relationship, right? You can draw a linear line here does not necessarily mean the chocolate consumption can make people smarter, right? That's not the causal relationship you can draw on. So you just have to be careful when you're interpreting this linear trend, right? Because here is also a linear trend, but there's no causal relationship between chocolate consumption and Nobel laureates. Right? It just happened. That's just what happened, right? Just like on May 31st, it's my birthday. It also happened to be on the day of the NBA final game. And those people showed up in the downtown Toronto, not for me, right? Not because it's my birthday. Time series, right? Time series, you can see visitors per month versus the temperature, right? When the temperatures is very high, right? The peaks for those blue lines, it also happened to be the peaks of the orange line, which is for the visitors, number of visitors, right? On the Yellowstone Park. Okay, so you can see you monitor this information over a time period from 2014 to 2016, right? And you notice that at around July, right? Every year, that's the peak. So my prediction would be in 2017 July, there's going to be a peak where most the visitors will come. And then you see the valley happened in January, right? The valley mostly happened in January. So you can predict the 2017 January will have a valley, right? So does this make sense, guys? If this makes sense, please give me a thumb up. 1, 2, 3. Okay, thank you. And now prescriptive analytics, okay? Prescriptive analytics. This is one would be like, what should we do, right? What should we do? So this analytics will help us to identify the best possible option, okay, given the constraints of changing conditions. So I'm gonna use this to show you a what if goal-seek analysis, okay? What if goal-seek analysis. So, so goal-seek analysis is actually a what-if analysis in the Excel. So you want to have a goal, right? You want to seek a goal. Let's say I want my final grade of this course to be 90%, right? So then you ask yourself how much I need to get from my exam 3 in order to get overall 90%, right? Right? You know all the other components, you know the marks, right? Now you only have one component left. That's the exam 3. And you know your goal is the final grade is to be 90, more than 90. So then you want to know how much, what's the minimum you have to achieve in exam 3 in order to achieve the overall 90% goal, right? So you calculate backward. Okay. So basically, do you have your Excel with you? If you don't, let me open mine. Where is my Excel? So I'm opening my Excel. Okay. So I'm going to show you this really cool tool. Okay. So suppose, let's see. Can you see my my Excel sheet? Suppose you have assignment. Oh, thank you, Danny. Thanks for letting me know. Suppose you have assignment. Oops. You have assignment. You have quizzes. You have exam 1, exam 2, and exam 3. Suppose the weight is here is 10%, 10%, 20. No, I don't want to, I use 15. Okay. So let me use 20. Okay, let me see. 15. I need 30, 60. I will need 15. 24, 72, 18, 9%. Okay, suppose this is 9%. This is 9%, 18. 18, that would be 82. Sorry, 82. So maybe this is 14%. So 14%, take 2 is 28, 72, divided by this, 3, 24, 24, and then 24. So that's add up to be, this should be add up to be 100%, right? But why? Why is 0? Okay, so this one should be 14 plus 14, 28. This is 72, so that's 100%. Okay, so that's the weight. Suppose your actual score, okay, this one, let's say you get, for assignment, you achieved 91%. For quiz, you achieved 82%. Exam 1, 92. Exam 2, 88. And then we don't know exam 3, but you want overall, you get a, overall, you want to get 90% to achieve a goal of 90% final grade. Okay. So I'm going to calculate my final grade, right? My final grade, so you use 14% times 0.9y. This should be just, the weight should be just 14, no, 14%. Okay, so let me redo this, okay, sorry. Okay. So I don't need a percentage, I just need a regular number. So 14, 14, 24, 24, 20, 24. So together, this is my 100. So that's how the weight of 100 assigned. So now I'm calculating using my actual percentage times the weight. Okay. So for this component, assignments, quizzes, exam 1, exam 2, I get these marks. And the exam 3, I don't know. Okay. But my final will equal to these ones. Right? Okay, so right now, with no exam 3, my mark is 67.42, right? and this exam 3 here is empty. Okay, so I want to know what percentage, so this times this, okay? I want to know what's the actual percentage, okay, of exam 3 can help me to get an overall 90%, okay? So now I'm gonna do a what if analysis. What if this number I10 is 90? How much this G9 should be? I want this cell, I want this orange, I want this yellow cell to be 90, right? And I want to know what's the percentage of the exam 3 is. So this is the green part, okay? So I will go with data, and I will look for what if analysis. I will go seek, set cell. What's your goal, right? Your goal is your final grade. So you pick the yellow cell. That's your goal. And what's the number you want it to be? I want it to be 90. And by changing which cell? By changing the actual percentage for exam 3. So by changing the green cell. So I want the yellow cell to be 90, okay? And by changing green cell. So I click OK. Did you see that? So now my yellow cell is 90. So this tells me that my final grade is 90. My percentage wise for the final exam, exam 3, has to be slightly over 94%. So if you get 90%, too bad. You will not get overall 90%. So does this make sense? Do you like it? Do you know how to use it? Do you find this is pretty cool? So give me a thumb up if you think you haven't seen this before, but you feel it's pretty cool. Okay, awesome. So you get a taste of the benefit of data analytics, right? So you can even use it right away for yourself, right? So what's your goal for this course? And there's a quiz 8, exam 3, but you have 2 variables. That's not gonna work. You only have one variable. Suppose you finish the quiz 8. The only thing left for is exam 3. So you can use this analysis to work backward, right? To see how much you are at, right? Let's say I'm not that aggressive to get a 90. What if I'm just happy with 72, right? So then you go for what if analysis, go seek, set this yellow cell and make it to be 72, and then changing cell is a green color, and I say go, okay. Yeah, if you want get 72, you only need a 20% on the exam 3. Okay. Does anyone have any question on this one? This is just a quick example of a go-seek analysis under what-if analysis. If you want to know how to better use these tools, you may want to register for some of the Excel tutorial sections. Does this make sense, guys? Okay, so this is what you do. You go from data, and then you find what if analysis. You click that, and then you go by go seek. And then you are going to set the cell, which is the final grade, to a number, 90. And then by changing the cell, changing final exam percentage to make the total to be 90. Okay. And then you can see in this example, right, they have to get 93.33% to get overall 90%. Okay, so this is the Amazon AI machine learning. Okay, so once you purchase something, the Amazon will display many similar items or enhancing or complementing items. Because you buy one thing, you are more likely to buy another thing associated with this item, right? Because many times the different products, different things are connected, right? Are connected. So this website, Amazon, they're able to, based on what you just shopped, they will display these items that they think you probably are interested, you are going to buy. This is the story about the pregnant shoppers. So, the target know this pregnant shopper better than even the father. Okay. So to summarize, like average, like highest number, lower number, this is descriptive. Diagnostic analysis would be to find out some pattern, like the pattern of the lady shopping pattern, right? Predictive analytics would be using the cluster to see there are 3 groups, or using a linear regression to figure out that linear relationship. But be careful that you could have those associations, but that's not necessarily causal relationship. Okay, and time series we've seen, right, based on the historical pattern, right, we can predict the future. And for prescriptive analysis, I have just shown you a what if goal-seek analysis. When you have time, you could spend more time on Excel to learn about it. Popular BI, the business intelligence tools, you can see there are these popular ones, including Power BI, Microsoft Power BI. Okay. Okay, so I'm going to just stop here. Okay. Okay. Hopefully you have learned